Welcome back to our game development series where we developed a game of life, actually a simulation, and it's this, a simulation right here. And so far it's working perfectly fine. But what I want to do right now is I would like to be able to customize the starting pattern with which to initialize the simulation. So right now we're starting the software and it starts off a random pattern initially and then it does its own thing. But I think a good game of life, for a good game of life, you should be able as a user to set your own points and then start the game of life based on that. You should be able to set your own cells. And to do that, we have to register mouse clicks in this pane right here in this surface and create an initial matrix of that. And also we should be able to reset this. So what I want to do in this episode is implement user interactions. So how can we make the game of life usable to someone? And to do that, we will have to do something with the game loop, which is running down here. And I guess we have to check the events that have been fired. And the first thing maybe that I would like to do is I would like to check for the spacebar to be pressed. And whenever the spacebar is pressed, I would like to restart the simulation. Okay? Or maybe even start. So we initialize the game, display a fixed, display, and when we hit the spacebar, the simulation should start. Why do we do that? Because after that, I would like to draw my own pattern using the mouse and then hit spacebar and have my own pattern execute. So that is the idea behind that. So how do we actually retrieve the events related to the spacebar? SDL spacebar event. Let's just look for that. Handling the keyboard. And let's have a look at what is going on here. So there's an SDL keyboard event. It has a type, and the type is probably it's key up or key down. Yeah. So we might be able to check the event type here and do an if event type. Let's do an else if, just to be sure. If event type is equal to SDL key down, this means a key has been pressed. In this case, when the key has been pressed, we should be able to figure out that, or somehow cast the event to a key down event or a key event. Event.key key sim. Interesting. So what is happening here? So we're basically querying the event type. The event type is key down, just like here, or key up. It doesn't really matter, I guess. And then we retrieve the event.key. Why are we retrieving the event.key? I'm a bit confused because the keyboard event itself does not have a key field. Maybe we should look for SDL2 specifically. SDL key code looks like a good starting place. SDL2 events. Okay, here's a list of events that are available in SDL2. There's the keyboard event. Okay, I understand. We retrieve here, right here, we retrieve the SDL event. And the SDL event contains everything, or is able to hold all those fields. Probably most of them are null. But in case of a keyboard event, or in case of a event type that is key down or key up, the keyboard event will be filled. And that is why right here in this if clause we can call event.key, and that is going to access the SDL keyboard event. And let's look for the definition of that specifically in SDL2. That is SDL1. Probably the definition is still the same. So let's just go into this documentation right here. And then there's a type. Okay. There is a type that is key down or key up. Okay. And then there's the key as well. And for the key, we get a key code. Event key. Wait. That is the key event. And then if we do key.key, I think we can access the key code. So let's look for that. And the SDL key code is going to be, well, here we have to get somehow the space bar. Let's have a look. SDLK. Right. And then there should be space. Good. Okay. So the key should be okay, let's do this. Event.key. This gives us the keyboard event. If we access key on the keyboard event, that gives us the actual key pressed. And we can compare it with SDLK for key. And then there should be a space. And there it is. And let's just do a print out space pressed, just to check that the key recognition works. Okay, so the key.key somehow is not valid. The keyboard event has no member named key, so maybe something was wrong with my documentation understanding. So here the keyboard event has a key, but this is SDL3. Let's look for SDL2. And yeah, so you should always look for the right documentation, obviously. So I need to get the equivalent of that key that is actually pressed. And that is the key sim and not the key code, I think. Let's look for key sim. Right, and okay. We have to do .key, that gives us this right here. No, .key sim, and then we have to check .sim. So let's change this to key sim, key symbol, .symbol. Event. Okay, the event has no... I think we need to do this. Yeah, because we first have to get the keyboard event, then on the keyboard event we get the key symbol, and from the key symbol we get the actual symbol. And what is the key symbol here on the key sim? Why does it need to be structure and not just a string? It contains the key modifiers, for example, whether control was pressed, and these kinds of things. Well, okay. If this works, I'm happy. So let's see if we can compile this. First, I have to adapt my compilation command because this is different one from a different project. Okay, now it should be adapted to Game of Life. It's compiled and okay, Game of Life is going on. And let's press the space bar and observe in the bottom right pane whether we get a space pressed. Yes, 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 yes. But why is there a dot before the space pressed? Okay, I'm stupid. I put a dot after the new line. But okay, so that means our key recognition works. Oh, key recognition, that sounds so fancy. I mean the event recognition or event polling. So space is being pressed, that works. And if space is being pressed, then we this would be a place for a go-to statement. We could just do go-to and then go to here. So jump back in front of the simulation loop. But everybody always says that this is a bad practice. Why? I mean, here it sounds really good, actually. But okay, let's just say simulation ongoing is false. So we don't want to simulate now. And if space is pressed, what do we do if space is pressed? If space is pressed, we would like to reset. We would like to initialize the game matrix again. So let's just copy that. Oops. Okay, initialize game matrix again. And let's see what happens. I think the simulation will exit now. I press space and it exits, yes. The reason is that simulation ongoing is now 0, and this means that the while loop here, the entire simulation loop, is being quit. So maybe we should introduce another variable, something that indicates that we reinitialize things, or that we at least that we put things to a stop and wait. How do we do that? I mean, I could do another loop inside this right here, but it wouldn't be nice. But maybe it's necessary. Wait, so let's just say let's just do the following. Maybe this is a good intermediary step. We say simulation halted or simulation paused. And simulation paused is 0. No, let's start with 1. And this right here, the simulation ongoing, is a bit misleading because this is the game loop. It should always be 1, except if the game loop is quit. Game loop. And if the game is quit, then we change game loop to 0. If we press the space bar, however, we don't interrupt the game loop, we keep it running, but we say simulation is paused. And then here we can say if the simulation is not paused, Then we do all of that stuff. No. Then we do all of that stuff right here. Else, that means the simulation is paused. We do, so if the simulation is paused, we, what do? We just introduce a small delay so we don't poll over and over and over again as far, so we don't consume too many CPU cycles. So we do a delay of 500, for example, or let's do 200. Okay. And this should actually allow us to pause the simulation at a key press. Okay. Now nothing is happening. If we press the spacebar, oh, still nothing is happening. Simulation is paused at the beginning. Of course, we have to somewhere we have to say that the simulation is not paused again. So here, when we press the spacebar, we toggle whether the simulation is paused. Like that. So if the simulation is paused, then after pressing the spacebar, it's not paused anymore. And if the simulation is running, after pressing the spacebar, the simulation is paused again. So that should be working. So now it's going on, it's happening. And now I press the spacebar again and it's paused. Great. Okay, this is quite nice. So let me just resume it and pause it again. Resume and pause it again. Perfect. And we can still exit it. Why can we still exit the simulation or the software? It's because we do this right here. We still... no, bullshit, sorry. It's because we still poll for events and don't just quit doing everything. Okay. So what I still don't quite like is that when we start the application, we have a plain black window. I would like to be able to see the initial game matrix, drawn. So we can do initialize game matrix here, and we can actually already draw the game matrix here. And maybe we should also draw the grid. And probably we should also update the window surface. So let's just compile, recompile, and start again. And as you can see, this is our initial set of data. That is the randomly generated data. Now, once we press the spacebar, the simulation starts. Yeah, perfect. Okay, so pressing the spacebar is for pausing and resuming the simulation. Now, maybe we should check for the key press of enter, and enter will reset the simulation. Let's do that. Else if event type STL key down. No, okay. We need to copy that block of code and do SDLK enter here, not end. Oh, does enter even exist? Then it's probably return. Is it return? We have to check that later. And if return is pressed, this resets the simulation. And let's just say we initialize a new game matrix. Okay. So this is our initial game matrix. We press space, the simulation does something, and now I press enter and it starts again. A new simulation restarts. Okay, and enter again and it restarts again. Enter again and it restarts again. So that's working well. What happens if I press space to halt the simulation and then press enter and then space again? Yeah. Okay, that maybe we should be able to visualize the reset when the simulation is paused. So I'm pressing space, simulation is ongoing. Now I'm pressing space again. I'm pressing enter, so this now resets the simulation, but the reset is not being shown because it's only drawn in the next simulation step. And when I press space again to resume, then we start from scratch. So this is not quite nice, so that's why I would like to... Oh, yeah. And I would like to draw the game matrix here again. So now I would expect space to resume, space to halt the simulation, and enter to reset. Perfect. Great. That's awesome. So we actually have some user mechanics now. Of course, the user can only initialize randomly. And what I would like to do is on enter, or no, I would like to introduce a mode where we start off a completely blank screen so that the user can later draw into the grid. So this is pressing enter now. Maybe we should use enter to instead create an empty game matrix. But now it's actually working quite nice to create a random game matrix. So maybe we should use a different key for that. Which other keys are good for that? Let's see. We can press Control and Enter. Maybe that is too complex. Actually, all this randomness should be a special mode, I think. Actually, the default game of life should be user draws something and then the simulation can be started. So the game of life should not be such a randomized thing, and the randomization should be special. So maybe here, in case of enter, which resets the simulation and sets it to a random state, maybe here we should check that the control or some control modifier or something is used as well. So here there's a current key modifier. Current key modifiers. How do I identify the key modifier? I mean, this is a UN16, so I don't know. How to use that. Key mod. In SDL3, the key modifiers are defined. We might have to check if they are defined in SDL2 as well. So let's do that. Event.key symbol .key mod. It's just mod. And the modifier should be equal to SDL. What was it in SDL3? Key mod K mod does not exist in SDL2. Oh, bummer. SDL2 key modifiers. I mean, yeah, we could look for that now, but maybe that's just unnecessary complication here. Let's just do it differently. Let's keep things simple. We do SDLK and we do key backspace. No. Okay, we can keep the return key, so the enter key. And the enter key will generate a random initial pattern, as already shown. And the backspace, which is usually used for deleting stuff, will start off a blank state. So that, I think that is good. That's a good idea. SDLK backspace. Then we initialize the game matrix. So far, when we initialize the game matrix, actually what we do is we randomize the game matrix. So let me rename all the occurrences of that. Okay, and now I would like to blank game matrix. And blank game matrix is pretty much the same as randomize the game matrix. The only difference being that we initialize the entire game matrix using zeros only. Like that. Let's see if we can compile. Of course we can't compile. Yeah, because I forgot renaming the method to blank game matrix. Okay, so this is our initial matrix. If we press backspace, we get a blank matrix. So yeah, it's working great. And if we press space, we start the simulation. But of course, it doesn't do anything because, well, of a blank population, you can't start a population, obviously, except if you're God and you. That's the big question of science. Did life actually start this way? Because science always says Earth was a mix of many molecules and somehow randomly life initiated. And it's pretty much what you see right now. We have a blank screen. Physics, press enter or press space to start the simulation and nothing happens. Of course, because nothing is there. So yeah, big questions how that all went. Of how that turned out to be working. Okay, but anyways, if we press enter, we start the simulation using a randomized matrix. We press space, we pause, we press enter, we generate a random matrix. We press backspace, we delete the matrix. Random, delete, random, delete. Random, delete, random, delete. It's actually quite funny. Okay. And in the random matrix, I would now comes the interesting part. I would like to be able to put cells via mouse events. And well, there need to be some mouse events. And of course there is mouse motion event, mouse button event. Yeah, so let's have a look at how that works out. I have never ever used mouse events in SDL so far. So this is also my first time. So let's have a look at how the mouse button event is defined. So we have an event type that is mouse button down or mouse button up. And then, okay, we get double clicks, single clicks, interesting. What I would like is, X coordinates and Y coordinates. Yeah, right. Perfect. So let's check for the mouse button down event. We need to do that outside of the key type event. Right here. Else if event.type equals SDL mouse button down, it was. Let me just confirm. Mouse button down, yeah. And in case the mouse button is being pressed, what can we access here? The timestamp, window ID, which mouse it was. The button index, we don't need that. I just want to register a click and the coordinates. What is padding 1? No idea. Okay, but X relative to window. SInt, signed integer. Okay. What does relative to window mean? Because this right here is the window. Is the coordinate 0, 0 the top left corner of the entire user interface right here? Or is it this coordinate inside the pane, inside this surface? You know my question? So there's a difference here. So maybe we have to adapt for that later on. But okay. Relative to window. I'm not really happy with that actually. It's a bit ambiguous. But okay. So let's get the mouse button event.x. Int x is equal let's call it mouse. X is equal to event.x, and it's not an integer but an sint 32. So a signed integer of 32 bits. Event.x. Of course, we also need to access event.mouse probably, because that gives us the mouse event, the mouse button event. Let's check. Oh no, it's button. Okay. Button dot x. Then let's check the y coordinate as well. Actually, we can just copy that and replace that with y and replace that with y. Good. Then we can, so when the mouse is being pressed, I would like to set a cell. Set cell in game matrix. And we pass the row count just to limit the chance of out of bounds accesses. And game matrix, and we provide the button and the mouse X and the mouse Y here. Set cell in game matrix. Okay. Oof. Void set cell in game matrix. In S in 32 mouse X, S in 32 mouse Y, rows, int rows, int columns, and the matrix int array game matrix. And what do we have to do here essentially is we have to translate the mouse X coordinates to the actual game coordinates, to the actual matrix cells. So let's just model that in Paint, that problem, because it's not really trivial. So let's say this is our pane. And these are the cells we're dealing with. And the mouse is clicking right here. That looks ugly. Okay. So the mouse is clicking right here. Then we would get have to get wait, so this, can I type here? Yeah. This is probably the mouse X, and no, sorry, this is not the mouse X. This is probably mouse Y. Mouse Y. And this right here is mouse X. Mouse X. Like that. So we have to count how many cells fit into mouse X. Right here, the goal or the aim is to color this cell right here. If the mouse clicks here, we have to color this cell. How do we know that this cell is being clicked? We check how many cells fit into mouse X, and we probably have to add one on top of that and do the same for mouse Y. So one cell, one complete cell fits into mouse X, and because because this cell is complete, this means that the mouse is clicking a bit more to the right, meaning we have to add one. So let me just try to model that here. Mouse X divided by cell width plus 1. I think this would be the column. No, this would be the row index. So this would be int clicked row. No, this would be the clicked column. And then the clicked row would be mouse Y divided by cell width plus 1. Yeah, let's just try it. I'm not sure if we need the rows and the columns here yet. Maybe we will need them later. We just have to test first. And this will set game matrix. Oh, no, clicking into a cell in the game matrix should toggle the cell. So if it's dead, then it should become alive. And if it's alive, then it should turn dead. This means game matrix j plus columns multiplied by y, as this is the same access pattern as here, will be equal to this same value but inversed. Okay. And of course we also have to add the semicolons here. Something is still wrong in line number 249. So let me just enable line numbers 249. That is this line. Yeah, we have to add a semicolon here. Okay. Set cell in game. What's wrong with that? Let's make this warning message a bit bigger. 248 warning, implicit declaration of set cell in game matrix. We provide mouse X, Y, row count, column count, game matrix. X, Y, rows, columns, game matrix. I think something is wrong here. But what is it? Expected semicolon, comma, or bracket? No. Am I missing something? What's the definition here? Okay. That is wrong. Oh, still something is wrong. Yeah, of course. We have to change the axis here to J and I. Okay, let me delete that, and now I should be able to draw something. But I am not able to draw something. Why? I'm setting the cell in the game matrix. Aha. But I'm not drawing the game after that. So let's draw the game matrix, draw the grid, and update the surface. Oops, I did not want to resize that. So. Still does not work. Did I just compile? Oh, yes. Okay, I can place cells, but they don't place directly under the mouse cursor, as you can see. So they are a bit off. The reason is probably that the coordinates are really relative to this bottom right corner of the entire UI. Or maybe... No, it looks like the +1 is wrong. Let me just fix this +1 axis in the set cell in game, and then actually it should work. I'm not sure if that's specific to the dimensions I just picked, but okay, now it seems to set the correct cells, so that is great. And I can start the simulation from here, perfect. And I can stop it, and I can generate a random population, and I can reset it. So that is very cool. Wow, that's awesome, actually. But I want to test it if it still works when we generate new dimensions here. If we change the dimensions, let's change the cell width to 30 again and see if this still works. Okay, so I'm clicking here, works. Click here, click here, click here, click here. Seems to be working. And actually, it's very precise. Yeah, awesome. That's the game of life, guys. Worked out. That's the implementation. Let's just create a game of life rocket, and then I would declare this project successfully done. Game of life rocket. Or spaceship. It's this pattern right here. Let me just implement this pattern to confirm that we can. No, I don't want to do a big rocket. I want a small one. I mean, and if this works, then we can confirm that Game of Life is properly implemented. But it is properly implemented. We can already see that it's working. Okay, let me just take a screenshot of that rocket because we need to replicate one state of that. And yeah, let me just duplicate it right here. So there will be, oh, I can't, oh no, there's still a bug. What is the bug here? This works. I can even remove some cells. Yeah, I don't know what that bug was, but actually it looks fine right now. Okay, so let's build the rocket. 1, 2, 1, 2. I'm just using this screenshot as as a sample. 1, 2, 1, 2, 1, 2, 1, 2. Okay, let's start the rocket and see if it works. Ooh. Okay. Was it moving? Was it moving as this one right here? I think it was. Let's stop the simulation, edit this again. I find it so nice that I can just edit this however I want. This is awesome. Okay, I'm really happy with how that project turned out. I'm very surprised that we got the mouse events working the way we did. So for a good finish, let's try a huge game of life with a cell width of only 5. That I would just want something that looks crazy, because I mean we have all the parameters open to us now. Let's start that. Ooh, that looks fancy. So actually I love experimenting with that. Awesome, awesome. So cool. And how about a more moderate size of 10 as we had in the beginning? or as we had earlier on. This is the random simulation right here. And we can also reset it and create our own little patterns. Awesome. I'm really enjoying looking at this right now. But I guess it's time to end Game of Life. I guess it's time to end the Game of Life series, except if you have more ideas for more features, then we can of course extend this. But this right now is everything that I wished for in this series. It's awesome. We have full control over the sport. We can generate random patterns, start the simulation, we can stop the simulation, we can reset the simulation, we can draw our own Game of Life. This is completely awesome. And start the simulation again. Oh, this was a bad pattern. This was a bad pattern again. Yeah, we can just do so much. That's awesome. Okay, if you enjoyed this video, then please leave a like, subscribe, stay tuned for more series like this. If you have ideas for more series, please let me know. Especially those simulations are really nice to do, and they are really fun to implement in my opinion. So if you enjoyed this, please come back to this channel. I love doing these things, and I hope to see you soon. Bye bye.